Hello, pre-calculus student. I'm going to introduce the idea of sine and cosine for our trigonometry section. I'm going to make another video showing how you can use the sine and cosine functions to solve some pretty interesting problems. Okay, so basically trigonometry looks at triangles with their nice little angles. Because there's a neat property that if the triangles have the same angles, then the ratios of the sides will be the same. So even though we've got a big house and a little house, the ratios are going to be the same. And vice versa, if the ratios of the sides are the same, then the angles have to be the same. And that's where the trigonometry comes in. So, I said, what if the big house had 20, 20, and 30 for a triangle, and the small house had 5, 5, and 7.5? Are the ratios the same? Well, 20, 20, 20, 20, yeah, 5, 5. Okay, let's look at the smaller side and the bigger side. 20, 30. Now, is it equal to 5 over 7.5? The way to simplify this type of fraction is to use cross multiplication. And we call it cross because we are actually crossing the equal sign. So we take the bottom times the top, bottom times the top. So 20 times 7.5 equals 30.5. I have students, I draw the arrows this way so that you know that the 20 and the 7.5 end up on the left. The 30 times 5 ends up on the right. If you try to go down and then up, you start wondering which side, which one's on the left? What just happened? Okay, so cross, up. And we end up with 150 equals 150. These ratios are the same. And a really good example of this, easy to do. This is basic trigonometry. If you have a tall object where you don't know the height, and you have another object where you do know the height, like yourself. So I took some 6th graders out, and there was a flagpole, and we, how do you know how tall it is? Well, we use the idea that the sun is going to provide the same angles. This is flat ground, same angles. So the shadow on the ground and the shadow and the height, they're both standing upright. So we're looking at 90-degree angles here. If we could measure the shadow of both shadows and then measure the person, we could use the idea that the ratios are the same to tell us how tall the flagpole was. So, okay, here we have our triangles, and let's say we have a 4-foot person with a 3-foot shadow, and then we march over the flagpole and we measure it, and we end up with a 21-foot shadow. So, how tall is the flagpole? Well, it's an equation, algebra, so we need a variable. Let's call it y because in the y direction, and gets us started nicely with the trig. So the ratio of side to side, side to side, y divided by 21, that's a ratio, equals 4 divided by 3. Okay, we know that the angles were the same because the sun, the ground, and the 90 degrees, the person wasn't leaning over either direction when we measured the shadow. So cross multiplication. So 3 times y equals 21 times 4, which was 81. And I pulled up my calculator and divided it, and it turned out y equals 28. I was really surprised. I thought it would be 0.333 or something. which lets us know that the flagpole is actually 28 feet tall. If the shadow's 21 feet tall. I think it was a little bit shorter. This is 6th grade. So elementary schools don't necessarily have big flagpoles. But this is beginning trig. Just knowing that the ratios will let you solve for something you don't know. If you've ever watched a surveyor, I have 2 pencils. So we've got 2 surveyors, and they have the same size pole. So one will march out a measured distance, and then they can measure the angle and see if the ground is still straight. Or they can walk out and let's figure out how far away it is. If we know the angle, then we can, they can start figuring out all sorts of things. And it's really cool how the trig comes in. So, before I really went into sine and cosine, I wanted to let you know that the ratio 345 shows up in a lot of triangles, a lot of tests, finals, SAT tests, GREs. So if you have a 8-foot apple tree and a 10-foot ladder, what should be the ratio? How far away is the ladder from the base of the tree? Well, it'll be 6 feet because, multiply by 2. This is still a 3, 4, 5. You have a piece of paper and you're cutting it. One side's 15 centimeters, the other's 20 centimeters. How long is your cut going to be? We're going to cut 25 centimeters. Still a 3, 4, 5. I just multiplied by 5, by 5, by 5. I put in yards and I thought, okay, football, yards and football. Those are really big units. But you notice it's 3, 4, 5 again. Just multiply by 100. So this is a special triangle, and it helps us introduce Pythagorean theorem. So, a right triangle. This is where I was talking about 90-degree angles, straight up and down, perpendicular. Why do we like right triangles? They're actually very sturdy. Okay, if gravity's coming down, you've got the whole, pencil, pen, flagpole. Okay, it's supported by all this. If the flagpole starts to tilt, then gravity really emphasizes that tilt and will pull it over. So these right triangles are very important. They're symbolized with a little square in the corner where it's 90 degrees. And they're also called square, they're not called square triangles. That's a stupid word. But the fact that you can fit a square into that angle is why we call it a right triangle. And then the theory says if you've got if the 2 sides, short sides, are labeled A and B, the long sides labeled C, then A squared plus B squared equals C squared. And he didn't necessarily invent this theorem. This has been known way before him because, people are trying to measure land. And you can actually cut up triangles. Okay, and so here you have A squared. So here's a square for A. And here's a square for B. And if you cut them up just right, you will fit them into a square for C. It's really cool. So 3, 4, 5, 3 squared plus 4 squared equals 5 squared. So we start giving these names like side, side, and hypotenuse. Or if we turn it on its side, put it, like inside a circle, then we can call it side or y, because it reaches the y on the XY coordinate system. And X, this side right here, just comes from, that's where it reaches. It goes over to X, it goes up Y, and there's the point XY. Now this is known as the distance between the center and the point. It's also known as the radius, or R, and this, let me go back. This equation right here can actually be, if you take the square root of both sides, then you just get C. That's known as the distance formula. Okay. And the angle that's coming out from the center is known as theta. And it's pretty important. And, okay, theta is not the 90-degree angle. It's not the pi divided by 2. It's a little bit smaller than that. And that allows us two really important functions, sine and cosine. They're abbreviated SIN and COS, but they are pronounced sine and cosine. And sine is the ratio of this y side divided by the radius, or the hypotenuse. Cosine is the x divided by the radius. And these two functions are the beginning of trig, and I'll be making another video showing you how to use these formulas. And just as a sneak peek, I'll be telling you about a Ferris wheel.